Today, we are going to learn how to solve such numerical problems with the help of logarithmic tables. In physics or in chemistry, you have so many calculations which cannot be easy to solve by a traditional means. In such cases, we depend upon logarithmic tables. These logarithmic tables were given to you. By using those tables, you can simplify the large problems. How it is useful and how it is easy to solve a problem with a using a logarithmic table. You know that subtractions and additions are easy than multiplications and divisions. So subtraction is easy for us, addition is also easy for us, but it is difficult to conduct multiplications or divisions with large numbers. In such cases, the logarithmic tables will help us. In logarithmic tables, there are two types of tables. One is logarithmic tables and other one is anti-logarithmic tables. You know, a into b, when turns into a logarithmic form, we can write it as log a plus log b. Or a by b can be written as log a minus log b. So by that way, when multiplication is there, simply by adding the logarithmic terms, you will get the log value of the product. Similarly, when there is a division, by subtracting the logarithmic values, you will get the logarithmic value of its answer. So that is the principle involved in it. So for that purpose, we need some tables which will give us log values for a given number, and after substitution and simplification, to get the final answer, we require another table which can convert the log value into a normal form. So the tables which were used to convert a normal value into a logarithmic value are said to be logarithmic tables, and those tables which are used to convert logarithmic values into a normal value or a numerical value is said to be anti-logarithmic tables. So by using these tables, you can easily calculate these problems. Now let us see how can we calculate it and how can you solve this problem. For example, here we have one problem in which we have 24 into 1234 into 9 by 2 into 1241. So if you use traditional path, you can cancel it to a certain extent, but it's very difficult for us to get the final answer. So if you use logarithmic tables, it is very easy for us to get the answer. So here what you have to do, you have to take log value of 24 plus log value of 1234 and log value of 9, and on adding all these things, you will get the logarithmic value of the numerator, the sum total, that will be the log value. Now here also you have log 2 and log 1241. By adding, you will get the log value of the denominator. So by subtracting the log value of this from this, you will get the log value of the answer. So let us see how we are going to get it. So here in the logarithmic tables, if you observe in the logarithmic tables, here you have certain numbers, that is horizontal column and a vertical column. horizontal column and a vertical column. In vertical column, you are starting from 10, 11, 12, 13, 14 up to 54 in one page. In the next page from 54, 55 to 100 you will have, 99 you will have. And this is in the horizontal column 1, 0, from 0 to 9, and again here you have 1 to 9 numbers. So here what you have to do? Now the thing is, here if you want to get the log values of these numbers, log 24. Log 24 is a 2-digit number, because 2 digits are there, 1, 2, and here log 1, 2, 3, 4 is a 4-digit number, and log 9 is a single digit number. So in log values you have two types, two things. One is characteristic and other one is mantissa. One is characteristic and other one is mantissa. The characteristic will depend upon the number of digits that were present in it. The characteristic of a number will depend upon its numericals. That is, in 24 you have 2 digits. So its characteristic is 2 minus 1, that is equal to 1. 1, 2, 3, 4, whatever the numerical value it may be, but the number of digits are 4. So its characteristic is 4 minus 1, 3. Here you have 9. Only one number is there. So its characteristic is 0. So characteristic is n minus 1, where n is the number of digits present in that molecule. In that number. Number of digits present in that number is said to be characteristic. For 24, number of digits is 2, so characteristic is 1. Even for 11, characteristic is 1, and for 99 also characteristic is 1, because both will have same number of digits. Similarly, in this number, in the second number 1234, you have 4 digits, so n minus 1, 4 minus 1, 3 is the characteristic. Then 9, now only one digit is there, so its characteristic is 0. Now the thing is, the value of this number 24. So the logarithmic value of that 24, that value is said to be mantissa. Total characteristic and mantissa both will give us the value. So characteristic will depend upon number of digits present in it, and mantissa will give you the actual value of those digits. So for 24, what you have to do, here you have this table, logarithmic table. Here you have 10, 12, 10, 11, 12, 13, 14 and so on. So now what you have to do, you should take 24 against 0. 24 against 0. Here the number is 3802. 3802. So for 24, the log value is 3802. 24, 0, 3802. Now, here 1, 2, 3, 4 is another number. So 1, 2, 3, 4. 1, 2, 3, 4 means first two numbers, 1 and 2, should see in this column, vertical column, and third digit is against that vertical column in the here. So here it is 12, 3, 0, 8, 9, 9. So for 12, 3, but here fourth digit is there. So this fourth digit you should take in here. This 14. Fourth digit is 14. So 1, 2, 3, 4. So 1, 2 against 3 is 0, 8, 9, 9. For that you have to add this one, 4, 14. If you add 14, 13, 11, 9, 0, 9, 1, 3. So for 1, 2, 3, 4, the mantissa is 0, 9, 1, 3. 0, 9, 1, 3 is the log value of 1, 2, 3, 4. Because it is 4-digit number, so its characteristic is 3. And log value is for 12 against 3, the log value is 0, 8, 9, 9, and in the mean difference, fourth digit should be in mean difference. That mean difference is 14. So on adding, you will get 0913. For a 9, what you have to do is a single digit number, so you have 0 there. So you should see 90 against 0. In logarithmic tables, in the second page, you have 90 against 90. If you observe the 0, the value is found to be against 90 0, 9542. It is 9542. Now these all are multiplications, so you have to add all the things. 3 plus 2, 5, 5 plus 2, 7, 4 plus 1, 5, 14, 14 plus 8, 21, 5, 9 plus 5, 14, 4 plus 1, 5. So this is the 5.4157. So 5 is the logarithmic, the characteristic that indicates that 5 indicates that the product of these three is a 6-digit number. The product of these three is a 6-digit number. That's why you got 5 as its characteristic. Now let us see the values in the log 2. In log 2, number of digits are only 1, so characteristic is 0. Characteristic is 0. So log 2 value, if you see in the logarithmic table, 20 against 0. 20 against 0. So 20, 0. So it is 3010. 3010. Now here you have 1 to 41. Sorry. 1 to 41. So 12 in the vertical column and 4th in the horizontal column. That is, see here, 12 against 4. That is 0934. For this we have mean difference 1, 3. You have to add 3 to it. So 3, 4, 3. If you add 3, you will get 0937. So this value is 0. This is 3.0937. On adding, you will get 749. So 3.3947. That is the product of these two. The product of these two will have 4 digits. That's why characteristic is 3. Now it is divided by this. So you have to subtract the log value of this product. From this product of the log value of this, it should be subtracted the product of log value of this. That is 54. You have to subtract this one. 3.3947. On subtracting, you get 0, 1, 2, 0, 2. This is the log value for the answer of this problem. So you should convert this log value into normal value. So to convert the log value into normal value, you have to depend upon anti-logarithmic tables that were also given in your material. So go through it. So in anti-log tables, you will have certain difference. That is, here the logarithm table starts from 10, but here it starts from 0.00. So from 0.00, 0.01, 0.02 and so on up to 0.99. The rest of the things are same. So now to see anti-log for 2.0210. This is characteristic. It decides the number of digits. That means that the answer is 3-digit number. But what is the answer? You will get it from this. 0.02 against 1. 0.02 against 1 is 1050. 1050. So 1050. Now here the last digit is 0, and if you go through the mean difference, that will also be 0. Now it is 3-digit number, but in answer you got 4 digits. So put point here. 105.0, so that it will become 3-digit number. So 105 is answer for this problem. 105 is the answer for that problem. So it is very simple to solve the problems by using these logarithmic tables. First, what you have to do, you have to convert these values into logarithmic values. If they are multiplication, you add all those things. Log 2, 24. Log 24 is a 2-digit number, so its characteristic is 1. In logarithmic tables, 24 against 0 is 3802. That's why the log 24 value is 1.3802. Similarly, for log 1, 2, 3, 4, the number of digits are 4, so characteristic is 3. Then 12 against 3 plus 4. Adding the mean difference, 4 value for the mean difference, you will get 0913. So log 1, 2, 3, 4 value is 3.0913. Similarly for log 9, it's a single digit number, so its characteristic is 0. And 90, 0, it is 9542. On adding all these things, three things, you will get 5.4157. That is the log value of product of all these numerator. Now, here in denominator you have 2 into 1241. Log 2 value is 0.3010. Then 1241, this is a 4-digit number, so its characteristic is 3. Now 12 against 4 plus mean difference 3. 12 against 4 you have 0934. In 1 mean difference 1 you have 3. So the total value for log 1241 is 3.0937. These two are multiplications. So on adding this, you will get 3.3947. So you have to divide with this. So subtract this. So 5.4157 minus 3.3947. On subtraction, you will get 2.0210. This is the log value of answer for this product. But we need answer. That's why you use or depend upon anti-log tables to convert this log value into normal value. So for that, you have to use anti-log tables. In anti-log tables, you have values from 0.00 to 0.99. So now here 0.0 against 1, if you observe, it is 1050. Here characteristic is 2. So characteristic 2 indicates that the answer will have only 3 digits, but here you got 4 digits. So just put 1 point here so that it becomes a 3-digit number 105. So the answer for this problem is 105. So it's very easy to solve such problems. So first time, if it is a first time, you may have a little bit confusion or difficult. But if you do 3 or 4 problems, you can understand it is very easy to solve such problems by using logarithmic tables. Let us solve another problem using these logarithmic tables. So here we have a number 7 into 1272 into 36 by 4 into 3424. So in numerator you have 3 numericals which have to be multiplied, and in denominator also you have 2 numbers which we have to multiply, and you have to divide that also. So for this is a long process and time taking process. To avoid this, we can depend upon logarithmic tables. So because we have already discussed that multiplication and division are more difficult when compared to additions and subtractions. So if you convert these numbers into logarithmic forms, if there is a necessity for multiplication, simply by adding the logarithmic values, the product of the multiple will comes. If there is a division, then you have to subtract the logarithmic values. Now here the 3 numbers in the numerator which you have to multiply are 7, let it be log 7, and 1272, let it be log 1272, then the third one is log 36. So we have already know that in a log value you have characteristic and Montesa. The value of the characteristic will depend upon the number of digits that are present in that numerical. So here in 7 only 1 digit is there. Here in the 1272 you have 4 digits. Here 36 2 digits are there. So the number of digits, if number of digits is n, the characteristic will become n minus 1. That means here 7 is there. So n is equal to 1. So characteristic will become 0. Here 4, irrespective of the value of its number, the number of digits is 4. So characteristic will be 3. 36 and 2. So its characteristic is 1. So characteristic is independent of the value of the numerical. It only depends upon the number of digits that were present in it. For 1111 or for 1000, the characteristic is 3, whereas 9999 also characteristic is 3, because 4 digits least number is 1000 and 4 digits highest number is this one. For both these cases, characteristic is 3 only, because it's a 4 digit number. Characteristic won't depend on the value of the numerical. It only gives us the number of digits that were present in it. Then Montesa value will depend upon the value of the numbers. So here in the logarithmic tables, you have already gone through it. Just go through your book. You will have the logarithmic books, where here if you observe, it starts from 10 in the vertical column, 10, 11, 12, 13, 14, 15 up to 99 there will be numbers. Then in horizontal column you have from 0 to 9, and again another horizontal column is there from 1 to 9, which we call it as a mean difference. So if the number is having first 2 digits of the number should gone through this vertical column, and the third digit you have to go through this, and fourth digit you should depend upon the mean difference. Now here in the log 7 you have only 1 digit. So here starting 2 digits are there. 10 is the 2 digit number, but here only 1 digit. So you should go through 70 0. 70 against 0. So see, 70 against 0, you have 70 against 0, you have 8451. So the Montesa value is 8457. So the logarithmic value of log 7 is 0.8451. 8451. Now the second number is log 1272. So here for this, the first 2 digits you should go through the vertical column. This is the vertical column. You have 1, 2 means 12. The third number is 7. So 12 against 7 is 1038. 1038. And the fourth number is you should go through mean difference, that is 7. So if you add 7 to this 38, it will become 45. So this log value of 1272 is 1045. 1045. 12 against 7, 1038. Mean difference 7. So you add it. 15, 4, 1045. This is the logarithmic value of log 1272. Then log 36, it's a 2-digit number, so you have characteristic as 1. Now you have to see 36 0. It is 5543. So add all the things. Eight plus 5, 13, 10, 7, 15, 5. So this is the log value for the product of 7 into 1272 into 36. Now, let us see the log value for 4, log 4 and log 3424. So log 440. So you have 40. So 0.6020. Then 34 against 2. 3, 4 against 2. 3, 4. Here you have 3, 4. So 3, 4 against 2. 3, 4 against 2 is 5, 3, 4, 0. 5, 3, 4, 0. And fourth digit is also there. So fourth digit you have to depend on mean difference. The mean difference is 5. So you have to add 5 here. So 5, 3, 4, 5. So since it is a 4-digit number, the characteristic will be 3. Now add these two. 5, 6, 3, 11. So 4.1365. So you have to subtract that from it. So the log value of this product is 5.5039 and the log value of the denominator is 4.1365. Then subtract it. 4, 7, 6, 3, 1. 1.3674. So if you go through these logarithms, 0.367. So here you have 0.36, 0.36. Here you have 0.36 and 7. 2328. 2328. And mean difference 4 you have to add. You have to add 4. 2328. You have to add 4. So it becomes 2332. So this is the answer. 2332. But here this characteristic is 1. Characteristic 1 indicates that the answer will have 2-digit number. So answer is 23.32. 23.32. So here answer for this problem is 23.32. Now it may feel little bit easy when compared to previous problem because you have some knowledge about it. So let us verify it once again. Here we have a problem. This was the problem where 7 into 1272 into 36 divided by 4 into 3424. Now here for simplifying we are depending upon logarithmic tables. Now we are converting all these numericals into logarithmic form. So in logarithmic forms, multiplication is nothing but addition of their logarithmic values. Division will be subtraction of their logarithmic values. For that purpose, we have taken the log values of numerator. So log 7 is equal to, since it is a single digit number, its characteristic is 0. Again 70, 0, it is 8451. So log 7 value is 0.8457. Similarly, log 1272, it's a 4-digit number. So its characteristic is 3. And its Montesa is 12 against 7. Go through the logarithm table, 12 against 7. Since it has a 4th digit in the same line, in mean difference, below the mean difference, you have to see against 2 what is the number. So on adding that 1038 plus 7, you will get 1045. So log 1272 is equal to 3.1045. Next log 36. Log 36 is a 2-digit number. So characteristic is 1. So 36, 0. It is 5543. Since they are multiplication, you have to add all the log values. So here it is 5.5039. This is the log value for the product of numerator. Now in denominator you have 4 into 3224. Let us convert that also into logarithmic form. Log 4, it is a single digit number, so characteristic is 0. 40, 0, because 4 is there, you have to see 40, 0. So 40, 0 means 6020. Then log 3224, this is a 4-digit number, so characteristic is 3. So in logarithmic table 34 against 2 and mean difference 4, if you add it, 5340 plus 5 mean difference, you will get 5345. On adding the both 4.1045 2.1365. This is the log value for the product of denominator. So now subtract the product of log value of numerator from numerator to denominator. So 5 point numerator log value is 5.5039 and the denominator log value is 4.1365. On subtraction you will get 1.3674. So this 1 is the characteristic of answer. So 1 means it is a 2-digit number, then only you will have 1 as a characteristic. So the answer is a 2-digit number. What are the 2 digits? So you should go to anti-log table. 0.36 against 7, you will have this value, and mean difference 4 is also should be added to it. Then you will get 2332. 2332. So 2-digit number. So 2.32 is the answer for that problem.